Okay, this is a quick video on how to process your bivariate investigation. Now, I've chosen exoplanets because nobody really chose exoplanets on their data. I wrote my purpose statement. So, purpose is to investigate, determine if there is a relationship between. Now, I went with rock and iron because that seemed to make sense, And so looking at this is the achieved portion of the schedule. Okay, purpose developed. I've said that on my purpose statement. Appropriate question posed. Yes. Plan outlines the process. Okay, so the plan again, you can get it from the actual practice ones. I don't care because they're all the same plan. All right, the plan. Now we have to identify the variables of units. So I've done that. The mass of rock. Now they were saying Earth masses in M, so I've just said what it is, and I chose it as predictor because I thought more rock would mean more iron. Okay, it doesn't even say you need to justify it here, but you do have to identify what units are being used to measure it. The mass of iron is also in M, is the response variable. So I've said those two. So that's a check and that's a check. You should also in your plan say what the source is. In this case, it was from Caltech, so I just said that. Now, a higher grade, you want to be able to actually, talk about do we think that's a good source, but here we just need to say what it is. Okay, we got our scatter plot. Again, because I said that rock is the predictor, it has to be on the bottom. If it's on over here, then it's not the predictor, and you're wrong. Everything you say will be off. Okay, there's the data. Now, from there, we got to say what the direction is. Direction of the relationship. Now, it's positive. Why? Because it's going up. Now, again, for the most part, you can just use visual clues. I'm going to throw in some numbers, too, because it's not hard, because we already have this summary, right? Everybody can get the summary. But again, just looking at it visually. Okay. Looking at it, again, I said it's positive because the trend line is going up and that the linear correlation, this part, is 0.95. Positive. If it was going down, it'd be negative 0.95. Strength, I think it is quite strong. Quite strong. Actually, we can just say strong because we know it's actually a 0.95, which is actually very strong. We know it is. Oh, what the hell? Let's go very strong. It is a very strong relationship because the points, especially at the beginning, hey, over here it's like almost right on the line. The points, I can put that in. Why not? Especially at the beginning, are very close to the trend line. Close to the trend line and stay fairly close at the right end. Yeah, why not? Okay. Okay, which is pretty much the case. Really close, and then they still stay fairly close. Okay, now we know the number. We'll throw in the number. Linear correlation is 0.95, and again between from 0.9 on, it's considered to be very strong, which is very strong. Okay. Next, look at the comment on it. Is it linear? Yes, I'd say it does look fairly linear. There might be a curve in there somewhere, but generally it looks very linear. First part looks kind of a curve, but let's ignore that. Okay. Linear? Question mark? Yes. The majority of the data seems to follow a linear pattern. Good. Next. Comment on that. Clusters or unusual values. There doesn't really seem to be any clusters or unusual values. Clusters and unusual. There does not seem to be any real clusters or unusual points in the data. Done. Next. Relationship described by an equation. We give the equation right there. Relationship equation. The relationship is described by the equation mass of iron. I'm going to put the unit M, which is capital M because it's mass of a planet, equals negative 2.42 plus 5.207 times mass of rock, also big M. Next, prediction needs to be made. Predictions. If, and again, you use a mass of rock to predict some mass of iron. Use this one to there. Okay, because that's my predictor variable was the mass of rock. So let's go prediction for mass of rock. Let's say 110. How about 10? 10 M mass of rock. Okay, if that's the case, iron equals equals negative 2.42 plus 5.207 times 10 equals, what's that, 5207 minus 49 point minus 42 minus 35 minus 265. Okay. M, make sure you include the unit. Okay. The prediction for 10 M mass of rock on exoplanet is 49.65 M of iron. Okay, so that just puts it in context. Okay, next. The problem is answered clearly. We were saying yes. Yes, there is a relationship between the mass of rock and the mass of iron on a planet. It is positive and strong. It also follows linear pattern. That's it. Is it in context? Yes. There is a relationship, positive, strong, and that's done. We can do one more prediction just to be good. I think I still got some time on this video. I only got 10 minutes allowed for it, so for the free version, 20 M mass of rock. I'm going to just copy this all. Copy. Paste. Change that to 20. 20.